Alright, so let's do a simple summary of simple, fractional, and packed column distillation. Now, when we do distillation, the whole point here is to separate two compounds that have different volatilities. So a simple distillation apparatus is kind of what you see here. We have the distillation head, the condenser column, the receiving flask, and we've got this vacuum adapter if we want to attach a vacuum. And to attach our distillation flask, or distillation flask, take a round bottom and we would attach it directly here. So what's going to happen is that basically this is the equivalent of having one theoretical plate. Boils off the round bottom and the vapors get condensed and come down the column. Now, to switch this to something like fractional, there's two ways we can do it. One is that we can just add a condenser column, and this is going to be like a fractionating column because it's going to have multiple surfaces for it to condense onto. Or, if you're rich school, you've got a nice fractionating column like this. It actually has a bulb for each theoretical plate. So the difference between a simple and a fractional is that you're going to attach another distillation column to the distillation head and attach your flask there. Now, I'm a chemical engineer, I'm a purist, but I understand that chemists are not purists in this regard. There is a third type of distillation column which is referred to as a packed distillation column. Now, we're going to use this synonymously with fractional columns. Just keep in mind that if you do it with people outside the field of chemistry, they're not going to consider this a fractional column, they're going to consider this a packed column. Packed columns are basically the extreme of fractionating columns. So whereas a fractionating column like this, you've got one plate for the distillation flask, you've got 1, 2, 3, 4, 5, 6 theoretical plates in here. This can have on the order to dozens to thousands of theoretical plates. Oops. So these are your three types of distillations. Now, why would you use one over the other? Well, simple is more efficient, meaning that typically what we get is a very little loss of fluid to the distillation apparatus, and it goes pretty quick. The drawback is we don't get very good separation. So if we have two things with similar volatilities, we're going to end up not really getting good separation. As you start going from fractionating to packed or fractionating to much better fractionating, you end up getting much better separation, but the cost here is both time and yield. Any vapors you condense in this column are kind of lost to this column. So you're going to end up not getting as much recovery with a fractionating column, but what you do recover is going to be on the order of much better purity. So this is your review here of simple, fractional, and packed column distillation.